Hey everybody, this is the double check for 4.5. I'm going to go through a couple of the 3.0 and a couple of 4.0 questions. I'm not going to go through them all for the simple fact that obviously there's some repetition here and it's very similar, and if you have this style on one, you should have a style on the other. This is a 3.0 problem. I apologize for the fuzziness. It's a copy of a copy. Log base 5 of 2x plus 8 is equal to 2. If it's like this, and you've got your single log, write it as an exponential. So this will come down here and it'll become 5 squared equals 2x plus 8. And then from here, it's just, algebra 1. So you'll end up with 17 halves. And then just obviously double check to make sure that the answer works, because again, you can't take logs of 0 or a negative number. So if we ended up coming up with an answer that would force, in this case, the log base 5 of a negative number or 0 or something like that, like if you came up with x equals negative 4, you wouldn't be able to do that. Now, you can still have answers, x values that equal 0. You can have x values that are negative, because it would still be like here, if x was negative 2 or negative 1, you would get the log of 6, and you'd still be okay with that. This is the last one. Again, similar setup, 3 to the 4th plus 4m plus 5. So then you get 81 minus 5 is equal to 4m. 76 divided by 4, so m is going to equal 19. And ideally, you should probably put this in set notation, because that makes it look nice. And it will impress your math teacher and college professors and all of that other stuff. Moving into the 4.0s. Here, if you can get it so you have a log equal to each other. So remember, if log A is equal to log B, then A equals A, or A equals B, I'm sorry. So in this point, you're going to try to write this as a single log. So if I'm dividing two logs, or if I'm subtracting two logs, the difference of two logs is equal to the log of their quotient. So this is going to become x plus 4 on the top over x minus 4 equal to log base 4 of 3. So then at this point, because of that, the property over on the right, you get x plus 4 over x minus 4 equals 3. And once again, we'll come back to algebra 1. So then you end up with about 3x minus 12. So you become 2x is equal to 16. So x will equal 8. And again, double check that. Now, if I plug 8 into any of the logs where I have an x value, I'd get 12 and over 4, and that'd be okay. So it'd be okay there in terms of domain issues. This one's actually very, very similar to another one that we did. I really should have put some of the numbers out front. Oh well. Log base 3 of 6 over 2x plus 3. Now this one, some of you guys may just be like beside yourself, because when you multiply this out, you're going to get quadratics. Oh no. So 6 is going to equal x plus 1, 2x plus 3. So you get 2x squared plus 5x plus 3. Move it all into one side. Solve it however you want. Quadratic, factoring, whatever. So 2x squared plus 5x plus, should be, what, negative 3 equals 0. So we know one of them would be 2x if this is factorable. Another one would have x, and you'd have minus 3. Which would mean that if I had minus 1 and plus 3 here, the middle terms are negative 1 and x and 6x, so that'll work. So x is going to equal 1/2, or x is going to equal negative 3. So then at this point, again, you're going to go through and you're going to double check to see which answer works. Now here, if I take the negative 3 and plug it in, and it only has to be one place, but in this case it happens to work in both. you'll end up with a log of -2. And that's a no-no. So that means that that's not a solution. The 1/2 works fine. You can go 1/2. You can take the log of 1.5 or 4 when you plug that in. So your only answer is going to be 1/2. I think I've got one more here, and then I'll do one that would be kind of just, I guess, a bonus question. Why am I subtracting so much? Oh, well, not my loss. So log base 2. Now, obviously, you could also have these things be equal. So 8x is equal to 3x squared minus 3 by the time you do all that other stuff. Yada, yada, yada. That one you actually come up with an answer of 5 is one of them. But the one that I was talking about is this. I mean, so I could have, and I'm not sure exactly how nice these things are. That really shouldn't matter, to be perfectly honest, because you guys should be comfortable with getting decimals and such. Let's say log base 2 plus log of x plus 5 is equal to the log of twice the log of x plus 1. So when you get this, this is going to become the log of 2 times x plus 5 is equal to the log of x plus 1 squared. And then everything will drop. And so again, you're back to a quadratic. So then you take this and then move all of this stuff over. Probably should have just written this like 2x plus 10. And move all that stuff over. 0 equals x squared. Ooh. This is serendipitous. Not bad for making it up off the top of my head. And so you're going to get x plus 3, x minus 3 equals 0. So your two possible answers are going to be -3 and 3. Positive 3 works in both of them. -3 works here. That's okay. But it's not okay here because you're going to, so that means that that's going to go away. So my only answer is going to be 3. And generally, you're going to have one answer that's going to drop. Okay? So that should hopefully get you set on how to do most of them. If you have any questions, give me a yell. Obviously, rewind, watch it again as you need to. Talk to you later.